So let me build up to that. I'm going to build up to that question. Does that move left, right, or up, down?
Right.
Yeah, it would move right. You with me? Right? And does this move left, right, or up, down?
Down.
Down. You with me? Okay, so what I'm saying is, when it's inside with the x, it's a left-right thing. When it's outside, it's an up-down thing. So what would this do? Is it inside with the x? Is that inside with the x, for example? Is that inside with the x? No. Okay. Appreciate the easy questions. So if it's not inside with the x, it's not going to be left, right. It's going to be up, down. So it's going to be a down reflection. It's going to reflect around the x-axis. Does that make sense?
I put that though, and you marked it wrong.
Unable. Oh, you said y-axis. Yeah. So if it flips, this of course is the x-axis. So if it flips like that, it's around the x-axis. Yeah. I like it. Does that make sense? I mean, it's really kind of nice. If it's in with the x and the x-axis is left and right, it's going to affect the graph in a left and right. It's going to move it left and right. It's going to reflect it left and right. You guys with me? If it's not inside with the x, it's outside, it could go with the y. It's going to move it up and down. It's going to move it up and down. It's going to reflect it down or up, right? Maybe? Let that be nice. Let that be nice.
So what happens when you put them together, like, you put the negative before the absolute value of x minus 2 and then minus 2? I kind of have a hard time.
Wait, all right. So tell me what function you want me to look at.
Like a negative absolute value of, I don't know, like x minus 4.
Like that?
Minus 3.
All right. Okay. So let's list the transformations and list them in order. What's the only important thing that has to happen at a certain time here? What's the last transformation I would do? And again, it's order operations, right? Order operations basically controls a lot of things. So what would I do last? Down 3. I love it. So that's going to be the last thing I do. Ever. No. Down 3. So what are the first two things? The first two things, it doesn't really matter, to be honest, which order I do it in, but right 4. I love it. Right 4. Reflect. Reflect how? Reflect like that, or reflect down? Down, because it's outside. It's gonna be up and down. So reflect down. You could just say reflect down. I'll understand what you mean. Or reflect across the x-axis, right? Reflect down or across x-axis. Let me just stop for a minute there. See, that's one level. Sorry, do you see that? that's a big thing. That's one level of this problem by itself. And that actually really should not be that difficult, just to stop and look and say, okay, what's been added to the absolute value? 3 things. And what do they do, each of them? Just list it. So one mistake you guys make when I ask you to do transforms, you always have to graph the base, the thing you start with, right? So give me some, what I call anchor points. For the absolute value, what are some points that it goes through? The basic absolute value. 0, 0. 1, 1. Negative 1, 1. That's plenty. And is this cool so far? I mean, is everybody cool with how we got these things? If you can't make this list, ain't no way you're going to graph it correctly, right? Good. So now I take each point and I do these things to them. So if I take that point, right 4, 1, 2, 3, 4, reflect, bam, down 3, 1, 2, 3. I'm pretty sure I ended up in the right place. 1, 2, 3, 4, reflect, down 3, okay. I'm gonna need more down here. Okay. Then this one. Right 4, 1, 2, 3, 4. Reflect, bam, and then down 3, 1, 2, 3. Something went freaky here. Oh no, that's fine. That's fine. Okay, I'm too close to my graph. It's kind of weird. All right. And then which point did I not do? This is the bad part about keeping track of which point I've done. I've done this.
Yeah.
1, 2, 3, 4. Reflect, and then down 3. So it's going to be right there. So there's my holy macarones. How do I check that? Oh yeah, go ahead.
No, go. You finish first.
How do I check it? What's this point? I don't know if you guys can even tell. 1, 2, 3, 4, 5. -4, I think, is what I was going for. And when I plug a 5 in here, 5 minus 4 is 1. Absolute value of 1 is 1. -1 minus 3 is -4. That's how I check it. Right? Whatever point the graph goes through must work in the equation. That's the connection between algebraic and visual. Right? Maybe? Yes? Oh, sorry. You first and then.
So if it's inside the brackets, if there's a x minus 4 inside the brackets, then it goes to the right 4, right? You marked me wrong for that.
Sorry.
You marked me wrong for that. But I made an incorrect graph.
Yeah, right 1, and I think you went left 1.
Yeah.
Yeah.
But you, okay.
That's the problem.
Okay,
You said right
alright.
1, but then you
Okay.
went left 1.
All right.
Yeah.
I was just confused.
So I was just circling the right one saying, you said it.
Okay.
And then you did do it. Okay.
Yeah.
Oh, when you're doing your list of 3, does it matter what order?
What's the only one of those in this problem that actually matters? That we have to do last? Order operations. What would you do last here if I plugged a number in?
Down 3.
Yes, that has to be last.
Okay.
I love it. And technically, you really should be careful. You really should do this first, then this, then that, just to kind of keep it in your head that it should follow order operations. It just happens to be in this problem that it doesn't matter if you move it left, right, and then reflect, or the other way around. Are you guys with me? So order operations keeps things in track more than we thought.
So with the reflect down, what if like the -3 was a +3? Instead of,
If that was a +3,
yeah.
then the last thing I would have done is gone up 3. Yeah, so I would have went, like this point, I would have went right 4, 1, 2, 3, 4. I would have reflected, bam, and then I went 1, 2, 3.
So reflected is like go down 1?
Reflect means that, so for example, this point here, where is its reflection? Isn't this up 3? So wouldn't its reflection be down 3? So it's the same way when you're in the bathroom and there's a mirror, right? How far away is your reflection from the mirror? The same distance you are from the mirror, correct? Or at least this is what it looks like. Are you with me? So in this case, the reflection is the x-axis. That's where the mirror is. So if there's a point here, its reflection is there. The same distance away. Just like any mirror, well, any flat mirror.
And if there was a negative, if it was absolute value of -x, it would reflect over the y-axis?
That's right, and that would actually stay the same.
Right.
It would just flip right on top of itself.
Because it's an absolute value.
Yes, absolute value would just look at the negative and go, who cares?
That makes sense.
Yeah.
Okay.
But that's a great point. So, real quick, on the heels of this reflection business, any other questions about this one? What would be the difference between this and this? Which one of these would reflect like, well, it's like this. Which one of those would reflect over like that? Reflect first one or the second one would reflect over.
Do you have that?
This guy.
Yeah.
It's outside, that's up and down. So this would be, I'm gonna do, this is not a good enough thing, yes? But if, let me do this. This is the base graph, its reflection will look like that. What about this one? It's gonna reflect how? Yeah, it's in with the X, left, right, so it's gonna reflect to the left. And if you give me these as answers, you will lose a ton of points, but I'm just making a point right now. You with me? Why would you lose points for this answer?
The graph was too pretty.
What's missing? Scale. Holy shit. Scale, some points, right? Because when you show me work, you have to graph points because your work would be moving the points. So I'm really concerned if I don't see any points. I'm like, how did you even do this problem, right? I'm hoping it didn't just come out of a calculator. So real quick, if I ask you to use transformations for a problem, you must list them, do a base graph, and then move it around. Right? I don't want to have the problem and all of a sudden there's a graph. No. I don't know if you made points like an XY table, because I don't want that at all. You shouldn't be doing that. Okay, maybe. Yes? Number 4. Oh, so real quick, if I gave you this, this line, what's its slope? So again? -4/9. So what would the perpendicular slope be? 9/4. I love it. All right, that's one thing by itself, right? What if I then said that the second line that's perpendicular to this one goes through 0, -5? Can you make the equation very quickly now? What 2 things do you need to know to make it the equation of a line? I think I'm almost awake. I'm sorry. Mystery liquid. I like it. What 2 things do you need to know to get the equation of a line? Slope and a point. Why does it kick ass if the point you know is like this? What's this? What's special about this point? It's a y-intercept. Right? Do I have to use that big ass line equation, y minus y1 equals mx? Do I have to use that one? No, because what letter do I know? B. Do I also know m? Shit, yeah. So what's the equation of line? 9/4 x
-5.
-5, because that's what b is, right? mx plus b. Now, your problem is almost this. The only thing I did to you that wasn't this was I didn't solve that one for y. The line equation I gave you wasn't solved for y. So if I give you, if I say I want to find the equation of the line perpendicular to 3x minus 7y equals 14, that goes through 0, -2. So what do I already know for sure about my answer? My equation, my line equation, what do I already know for sure? I just told it to you. You don't have to do shit for it. What do you know? Yeah, so I know B is -2. Check. So therefore, the only thing I need to know about my line still, so that I can just do it that easy, is my slope. to figure out my slope, I have to first know this guy's slope, right? And of course, what do I do to figure out this guy's slope? Why was this easy? Why did you guys tell me the slope so damn quick on this one? Why was this so quick? Why can you just see it? Because what form is this in? Y equals mx plus b, correct? And that's why you just went, well, of course, negative 4/9 is the slope, Jeff. It's in the right place. Can you do that for this? No? No, you can't. What do you have to do first? Solve for y. Yeah. Is that cool? So if you solve this for y, I'm just going to kind of do it quickly. Add, subtract, divide. What's this guy's slope? This guy's slope? 3/7. So what's my slope? Negative 7 over 3. And so y equals negative 7/3 x minus 2. Done. Is that all right? So I gave you the equation of a line. I said your line is perpendicular. Oh shit, I need that guy's slope so I can get my slope. And then I gave you the y-intercept, which means I gave you b. So once you got the slope, you're done, right? So I understand a lot of you guys were doing things that would lead you to somewhere, but not quite to where you needed to be. You were all trying to get points and so forth. So remember, when I say this, find the equation of the line that does stuff, right? Whatever the shit it does. What two things do you need? Slope and a point. What's the best point to be given? The y-intercept. What if I don't give you the y-intercept? You could use the y minus y1 equals mx minus x1 if you want to. Yeah. And again, right now, if you don't understand part of what we just did, I guarantee you that there's 8 other people that also don't. So I don't know if some of you guys are reticent to ask questions because you're like, I'm looking around like everybody else seems to get it. No. They are just good fakers. So feel free to ask. Does any part of that not make sense? Let me know. It's okay if it doesn't. It's not okay if you don't ask. Yes?
I don't understand how we went from 3/7 to 7/3. I mean,
Oh,
I get
okay.
their inverses, but.
Yeah, perpendicular. Perpendicular slopes
Oh,
are negative reciprocals.
Okay.
So if I knew this guy's slope, I can convert it into my slope because I know I'm perpendicular to him. Yeah.
okay.
I'll lock it. Him or her, I don't know. I don't know the biology of equations. Yes?
So going back to what she was saying, how are perpendicular lines different from inverse lines?
All right, so did they ever say inverse line? Do you mean inverse function?
Oh, inverse function.
Oh,
sorry.
okay. Well, all right, let's do this. I'm going to erase all this, okay? Somebody give me a nice equation of a line, like y equals, give me something kind of nice.
2/3 x plus 5.
Yeah, let's look at that. That's so cool. All right. Thanks, sir. How do I find the inverse of this?
Switch x and y.
Switch x and y. Solve for y. So I'm going to subtract 5. And then I'm going to multiply by 3/2. 11. Let me just clean this up a little bit. Is this cool? This cancels. So you get y equals, I'm going to distribute this. Are these perpendicular? No. I had to do an example to show you why they aren't the same. Yeah. So inverse function is not the same as perpendicular line, right?
But it's mirrored.
Hmm?
But it's mirrored.
across the y equals x,
Yeah.
that's, yeah, so that's why it's a little different. In fact, what is the inverse of this? So y equals x, it's its own inverse, right? So that's definitely not the perpendicular, it's its own inverse, right? Okay, good. But I understand how that can get confusing, but perpendicular means inverted and change the sign, right? So it's more than just inverse, yeah. Okay, I like that question. So now is the time, guys. Yes.
I didn't know what to do with the inverse of cube root.
Oh. All right. I'll leave this up here for a minute. So, Nicholas, how would you solve this equation?
Instead of cube root, you just cube it, right?
Yeah, you would just cube it, right? So x equals x. So if I had to find the inverse of, so start out with the cube root, I guess, right?
Yeah.
X plus 7 is 11. If I had to find the inverse of this, I would switch the x and y, right? And then you would do what next? Now here's where a lot of you guys made a mistake. Tell me again in equations, whatever I do to one side, I must do to the other side. So some of you guys did this. What? You can't just pick to just do this piece. How does he escape that shit? No, and this is why you do not want to cube right now, because if you cube right now, you must do it to this side. Oh, holy shit. I don't want to do that. Write it 3 times, distribute. No, so what should I do first? At 11, I want the cube root by itself, so that when I cube, the only thing it does is kill the cube root. I don't have extra shit to worry about, right? That's why I say isolate the radical. In general, you isolate the piece that has your variable in it. So add 11, add 11. All right, Nicholas. You told me what to do up there. What do I do down there? Just cube it. 11. And I think I told you guys, please don't do this. Just leave that, right? Thankfully, I don't think anybody tried to keep it out. And then the last thing, just subtract 7, right? So it'll be y equals 11. Yeah, there it is. Minus 7. So that's F inverse. Is that all right? Maybe? Okay. Some of you guys are doing stuff like, if I give you a function, you're telling me that F inverse is 3x plus 5 over 2, but, or something like that. I don't, or even somebody did something like, I mean, right? I mean, that kinda is close to some part of an idea that this is about, but why is that very, very obviously wrong? Well, here's a quick thing, watch. This function, it multiplies by 3, correct? So the inverse should at some point do what? Divide by 3. Okay, I know, right? This doesn't divide x by 3. This one does subtract 5 and this one does add 5, but it doesn't do the other things it's supposed to do. So you can't, the minute this function is at all involved, you cannot do this in one step. You can't. You have to switch the x and y and then do each step. Let the steps build it for you, right? Okay, maybe. How do you guys feel about finding inverses at the moment? Anybody feel like they still don't know what the hell to do? It's okay if you do. You gotta tell me. or just accept it. I don't know if you want, yes.
I'll be honest, I don't get it.
Okay. I noticed in the homework, some of you guys were every now and again just not doing the process. In mathematics, the process I use just basically never changes. Just the shit I'm doing the process to changes. So how do I always find the inverse given a function? How do I find its inverse? Switch the x and y, solve for y, right? Period. But some of us seem to like do it sometimes, and then in other problems you just don't do that. But that's it. That's the process. That's what you always do. So if I give you and I want to find this guy's inverse, right? What do? Switch the x and y. This is y, right? So I'm going to switch the x and y. And then just start solving. And again, notice, is it more pronounced now? Who do you have to take care of first? What do you want to move first? The 2. I want to get rid of that thing, so then I can attack this 5th power directly. So I have x minus 2 equals stuff to the 5th power. So what do I want to kill next? What's in my way? I want to get at the y. Why is the y stuck? Yeah, stuck in a power, right? So how do I undo a 5th power? Take a...
Radical.
Be more specific.
Fifth radical?
5th root.
Fifth
Take
root,
a 5th
sorry.
root. Are you guys okay? Are you guys okay? You gotta tell me. If I ask you what's the opposite of a 5th power, you should be like 5th root. That's the opposite, correct? The opposite of cubing something is cube rooting it, right? Okay, I don't know, I'm trying. You guys are giving me shit. Come on, you guys don't. So if that doesn't make sense, let me know. Let me know right now, because it's my job to explain it. But I can't if I don't know if it doesn't make sense. So right here, I want to kill that 5th power. Why do I want to kill that 5th power? Because I want to get the y by itself, and it's stuck. It's stuck in that 5th power, so I want to kill it. I want to knock it down. It's a freaking wall. Get out of my way. 5th root, die. So now I got the 5th root of this business equals 2y plus 7. Now I can start getting the y by itself, right?
It was the bug.
Huh?
It was the
Oh,
bug.
the button, okay. So what do I do next? Minus 7. Be really careful. Is this the 5th root of x minus 9? Hell no, that can't go in there. And then the last thing I do is divide by 2, right? And then I've got this is my inverse function. Yeah, gross, but who cares? Do you have to do much with that? Didn't you just move numbers around one at a time? Does that look nice? No. How did I get there? I put a number there, I put a number there, I put a number there. I mean, right? I mean, really think about, don't say that looks gross, it must be wrong, or that looks gross, I can't do this, that's weird. No, you're just moving numbers around, and they all kind of collect to make this gross thing, but it's not difficult. The steps aren't difficult. I don't know if that's any better. But if I give you a function and I say find the inverse, this is what you always do. Okay. And if I give you a graph and I say find the inverse, right, I think everybody did pretty well with that one. I just switch the x and y, just like I do with the function. I just switch the x and y. Okay. Yes.
So on the 5.2 homework on 11, there's f of x equals 3 to the x plus 1 power, and it's finding like the power functions. Can we kind of like review that?
What's it saying again?
F of x equals 3 to the x plus 1.
And it's asking for what?
It's asking, identify these as either a power function, polynomial function, or neither.
Ah,
So
okay.
just kind of like finding
So
those
give me an idea of
functions.
what a power function looks like.
Like x to the fifth.
Ah, so a power function looks like x to a number, right? That's what a power function looks like. It looks like x to a number. Is that what this is saying? No, this is a number to an x. That's some freaky stuff, right? We're going to talk about these functions later. They're going to eventually lead us to everybody's second favorite after word problems, logarithms. Right? I love logarithms, and I'm gonna make you love them too. Okay. So it's definitely not a power function. It's not x to a power. Right? Polynomials. What are they? Give me an idea what polynomial looks like. Let me give you an example polynomial.
X squared plus 2x plus 11.
Good. Somebody else give me a higher degree polynomial. What degree is that?
2.
Second degree. Somebody else give me a higher degree polynomial. Just give me a higher power than 2.
4.
So build it. What is it? X to the
4th.
4th. And you can stop right there. That's a polynomial, right? So polynomials look like combinations of these when the power is a whole number. Does that make sense? So it'd be like x to the 4th, x cubed, x squared, x to the 1st, plus a number. They're not going to have fractional powers. They're not going to have negative powers. Right? That's what polynomials do. So is this a polynomial? Nope. Because again, what would the base have to be in order to be either one of those things? The base would have to be x. And this just turned that around. This is called an exponential function, which makes sense, because where's the variable? In the exponent. So it's an exponential function, because math people were really creative. There's an exponent, it's called exponential. Yay. Right? That's basically us. Okay, is that better? Is that all right? Okay, so that whole thing about a power function is more general than a polynomial function. Very quickly, I don't think I said this directly. Why the hell do we call certain things polynomials? So can anybody tell me, based on what I just said earlier, is this a polynomial? No. Why is it not a polynomial? There's a negative power. Polynomials, the powers can only be whole numbers. Let's investigate why that's true. Anybody remember what a negative power does? What's a negative power do? Flip, right? 4-letter word starts with F. That's better to say in mixed company. So this would be 1 over x squared. Can I use any x value I want to in this? Is there an x value I'm not allowed to use? Think about it. This is 1 divided by x squared. I can't use 0. So polynomials have to be able to take anything. I have to be able to put whatever the hell I want to in them, right? So what's wrong with this one? It's got a fractional power, right? Polynomials have to have whole number powers. But again, what's wrong with this? What's a 1/2 power mean? It's another way to write a 1/2 power. Square root, because square roots cut things in half. That's why they connect to each other, right? Can I take the square root of anything I want to and stay real? Nope, right? Now the 1/3 power would be cool, but we just close the door. We just say, just to be safe, the powers can only be whole numbers, right? I like it. Maybe, is that all right? You guys remember that? So back in the day, you should have learned at some point polynomials and degree and leading coefficient. You know, monomial, binomial, trinomial, yes? And then after that, we just go poly. Anybody know what poly means?
Many.
Many, right? So we're like one term, two term, three term, many term. You know, again, creative power. Okay. Just to make sure, again, everybody has the practice test. Did anybody not get their quiz back? Because that's something else you could ask questions about is the quiz. What? Oh shit, I'm like not capturing. Anyway. Well, okay. So I don't know if you guys understand our review days or anything that hasn't made sense so far, you can ask. Yes.
Number 7 on the practice test?
Oh yeah, we gotta do that in class. I started doing them like, by the way, if I give you a test and it's got this much room on it, use scrap paper. Don't do like me. Yeah, I started doing them like, I'm not gonna have room for this, we'll just do it in class. Okay, so let's do it in class. So number 7, I'm gonna set up the long division. Is that -1? I gotta get a new printer, let's see. X to the 4th. Yeah, what do I have to be careful about the top? Which I think is another reason why I want to do it over. What's missing? X cubed. So what's the coefficient of x cubed?
0.
0. So I have x to the 4th plus 0x cubed. Become a 3. There we go. Minus 3x squared plus x. X squared plus x plus 5. Sure. Now this is, I don't know if anybody ever in their past thought about long division and you're like, what if variables were in there? Oh my God, that can't be true. Here it is, yay! So the same way that you have long divided numbers, we use that same way here, right? And again, I can't stress this enough. Variables are just numbers I don't know yet. So they have to act the same way as numbers do. So help me out here. X squared times what is x to the 4th? X squared. I love it. And right? Isn't that how we long divide? And then I just multiply this by this, right? X squared times x squared is x to the 4th. That's crazy. X squared times x is x to the 3rd. See how I'm lining up my like terms? X squared times -1. That's right, kids. Minus x squared. And then I do what? Change the signs. Now I know when we long divide, you wouldn't say change the signs, you would say subtract. But that's what subtraction is changing the sign of the thing. So I'm going to change the signs. Right, because isn't that how we long divide? You multiply the thing and then you subtract it. So I'm subtracting all of that, which means changing all of their signs. Is anybody lost right now? It's okay if you are. You just have to tell me. So again, we did an example. Let me do a different one. 58 into 6,047. Sure. That's not exactly the best. Oh well, too bad, Jeff. So when this go once, right, and then you just multiply, and then we would change the sign, right? Then you bring down the 4. In this case, I have to also bring down the 7, and then 5 goes into 24 about 4 times. That might not work. Let's see. Oh, it will. Yay. Right? Yes? So we're doing the same stuff here. x squared times x squared is x to the fourth, then you multiply, subtract, so these cancel. This will be negative x cubed minus 2x squared. Bring down the x. Is that cool? Right, just bring down the next thing like we do with numbers. And then x squared times what is negative x cubed? X squared times what is negative x cubed? Negative x, right? Isn't it just missing another x? So then negative x times x squared is negative x cubed. Of course it is, because we made it be so. Negative x times x is minus x squared. Negative x times negative 1 is plus x. And then I change the sign. Again, the same way we do with regular long division, right? These cancel. This is negative x squared, and these cancel. Neato. Bring down to 5. Might as well put like a 0x here. X squared times what is negative x squared? Negative 1. Negative 1 times x squared is negative x squared. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. Change the signs. That x plus 4. And then how do I write the answer then? It'll be x squared minus x minus 1. How do I do the remainder? Over here. 4 times 58 is 232. I get remainder 15, right? How would I write that here? Yeah, so this is plus, there's an understood plus 15 over 58. So how do I write this remainder? Plus
x plus 4 over x squared plus x minus 1.
Yeah. Okay.
When you're subtracting the x cubed from the very top, it was like, yeah, how come those don't cancel out?
You have nothing minus 1x cubed is negative 1x
Oh.
cubed. Yeah. So just look at the coefficient. 0 minus 1 is negative 1. Cool.
Why are you writing it at 0x?
Just so there's a place there. I mean, do you see how I got an x here? And if I didn't put that there, it might freak me out.
Okay.
I might put it over there, and some people tell me that it's 6x. I'm like, how do you add 5 to x? You know, so same kind of thing why I needed that there, just so I have a place for any x to go, right? So you didn't have to, but you just got to be careful about what you do with what you get from multiplying that. Okay.
Is that the same thing you do with the number 2 on the practice test?
Number two. Oh, number 2 is about the graphing calculator. Is that what you're saying?
Yeah, I don't really get the question.
Oh, use the graphing calculator. So put that into y1, and then get the zeros. Wait a second, maybe we'll do that together. There you go, start. These wait. Is this room? No, this room does have. No, you suck. Alright, so we're gonna do number 2 real quick. Yeah, there you go. That's gonna be useful. Zoom in. Oh wait, zoom it. There we go. Alright, so if I put into y equals, I think I have it in here, don't I? Isn't that it? Look at that. All right. Yeah, I just made the key a space, so I still have that in there. That's the function from number 2, right? X to the 4th minus 0.3 x squared minus 37.9 x squared. Sorry, x cubed x squared, 72.3, 80.1, okay. Is that cool? So just put that in there, and let this thing that costs so much freaking money do something for me, right? So if I hit zoom 6 just to start where it's probably going to look like for you. Look at that. That's crazy. Look at that. Okay. Now, to be honest, all right. I don't know if I can make this any better, so you can see it any better. Maybe it's a little bit better. I don't know. I've got to get them to install the emulator on the computer, so that would be better to see. All right. Bam. Can you see the intercepts? Can you see the zeros? How many do you see? 4. You see right there how it goes? Don't worry, we're going to zoom in on him so we can see stuff better. Now here's where things get weird. Would you say it's pretty steep? This function's pretty steep. Hell yes, right? One thing you could do, this is not what I did, but one thing you could do, if you have a really steep freaking function, you could do zoom box around each little intercept. So like I could do there, hit enter, move over, and I build a little box. I'm going to zoom in on that. See what that does for me. Still going to go straight up and down. Yeah, too much. But does anyone remember how to find the 0? It's kind of crazy. Does anyone remember how to make the calculator calculate something graphically? The top row is graphing stuff. Is there anything up there that makes it, that seems like it would be something that I would make the calculator calculate something graphically? Top row.
Second trace.
Second trace, because right above the word, right above trace, there's the word calc. So this whole top row is graphical stuff. Don't I want the calculator to graphically calculate something right now? So I'm going to go there. So hit second trace. And of course here, what do I want to find? Think you heard it? No? The 0, right? So it's going to ask us 3 questions. It's going to ask us for a left bound. And when you have a really steep, yeah, this didn't really help us at all. See how I have a really steep function? So when I'm moving around, it's really jumping a lot. I really want you guys to get this. What's the value of y right at this point? 0. So if I'm on the left side of it, I'm at a positive y value, correct? And if on the right side of it, I'm at a negative y value, yes? So watch the y value here as I move around. So I'm going backwards. Isn't it getting bigger positive? Okay. I'm going to move forwards. Didn't it just change to negative? You guys see the bottom, the y equals? Now it's going further down? All right, so I didn't make the best function in the world. It's very steep, but, so I can't see my cursor, it just jumps really fast. So all you do, if I want to be to the left of it, I go until I'm positive y. There, I'm positive y. I'm on the left side of the answer because I'm up here. Enter. Then I want the right side. Okay, the right side is going to be negative. Okay, now I've got some negative stuff. So now I'm on the right side of it. Enter. And now I want to get the answer. So I get close to y equals 0 because that's where the answer is. That's the closest I can get. So it looks like it's negative 6.7. Now real quick, my poor little calculator, such a steep function, freaks out a little bit. Anybody remember what that e means? Times 10 to the negative 11. So I moved the decimal back 11 times. This is the calculator trying to say 0, but it just couldn't resolve it good enough. It just sort of stopped, right? So this is the 0, negative 6.7. In fact, it tells me just so I know for sure. That's one of the zeros. Then I can go to the next 0, zoom in on it, do the same thing again, right? So real quick, let me hit zoom 6. So I can do the exact same thing here, but look at right here. I'm going to zoom in on that area. Zoom box is the coolest freaking thing. I just want to zoom right in to this area right here. Look at that. That's nice. Look at that little parabolic we could do. And then I can do what we just did a minute ago for this guy. And then for this guy. Right? So just have to do that 4 times. Now, so that's the calculator usage. Right? That's why it costs so much money, because it does this kind of thing. How many answers do I expect total? Looking at the function, how many answers, how many zeros, how many x-intercepts do we expect total? 4. How many real intercepts did we find? No, not, how many real intercepts do we see there are? 4, remember? Remember? There were 4, yes? I don't know what's happening. We saw, even though we don't know what they all are, 1, 2, 3, 4. Okay. There's 4 real intercepts, and we know there's supposed to be 4 total answers. Can there be any complex answers? Do we have any answers we're missing yet so far? Any answers we're missing? They're supposed to, listen, guys. What's the degree of the function? 4th degree. Fundamental theorem of algebra says I should expect the same number of answers as the degree of the problem. So how many answers do we expect? 4. How many of those are real? All 4. Any left over to be complex? Nope. So I expect 0 complex answers because they're all real. Now watch this. What if I were to do this? I'm going to change one number in here. I'm going to make this 90. Let's see if I got it far enough. Oh yeah, cool. How many real answers are there now? 2. So how many complex answers do there have to be? 2. Real quick, where do complex answers come from? Don't they come from quadratic formula? Right? That's because you'd have a square root of a negative number in the formula. Are you guys with me? Isn't there a plus or minus in there? So complex answers always have to show up in pairs. There'll be a plus 1 and a minus 1 because of the plus or minus. Yes? So that's good to know. Right? Okay. And if I added it, do you see the little snippet up there? Does anyone really understand what I just did? I just took the function and moved it up 10. That's why that little snippet is way up there now. See the little smudge there? That's the little thing that went like this. It doesn't hit the x-axis anymore. If I added a big enough number, I would take this, shoot it way up. There could be no real answers. They would all be complex. Okay. All right. So the most important thing from that whole thing is, are you able to find zeros in the calculator? Right. The second most important thing there is the theorem, the idea that the degree of the polynomial tells you how many answers to expect. And just so you make sure, and of course you guys didn't get any of that, I'm sorry. Anybody's home watching. Somebody help me out. What's the degree of this function there? 4th degree, yes? How many answers should there be? 4. And here, I'll write the answers for us. So the fundamental theorem didn't say they all had to be different. So I get 4 answers, they just all happen to be 2. You with me? Okay. Why is that? Because this would be x minus 2, x minus 2, x minus 2, x minus 2, and 2 makes them all 0, so that's the only answer, but it shows 4 times. It's got a multiplicity of 4. it's wide open right now. It's just wide open. If there's something already discussed and you're like, I still don't get what the hell you're saying, man, can you try it again in English, right? Maybe don't say it that way, but you can think it that way. Or if there's something we haven't talked about yet, right? Factoring, synthetic division, the whole number one problem with end behavior and all that, right? That's the most recent stuff. Yes?
Number one C.
Oh, so we found, what was it? X minus 2x plus 3 squared. Right? So we found 0, 0, 2, 0, negative 3, 0, right? For the roots. What's the multiplicity for these guys from where they came from? So they came from these two, right? What's their multiplicity? What's the multiplicity of this one, which is where he came from, right? This has multiplicity 2. Which means what's it going to do at negative 3, 0? Is it going to go through or is it going to turn? It's going to turn. It's going to do like a parabola would. Right? What's the multiplicity of each of these?
1.
Understood 1, right? It's odd. So if it's even, it turns like parabola. These guys are odd. Look out. These guys are odd multiplicity. So what's it going to do in each of them? It's going to go through. You can even spell it correctly if you want to, but I don't have time for that. Ain't nobody got time for that. Is that all right? So then when you graph it, let me see. This problem was the end behavior it's 1 plus 1 plus 2. So it's got a 4th degree end behavior, right? So when I plot these 0, 0, negative 3, 0, 2, 0, this is not good enough to turn in, by the way, right? It would start up here, and I know as I'm coming down here, it's going to turn here. Yes? Which is why it's really good to put one of these numbers in the function to see how tall it gets. I'm also going to have the y-intercept and blah, blah, blah. And then here's going to go through, and there's going to go through. So maybe I want to know how deep this is too, right? So I kind of know what other numbers. That's why I put f of negative 1 and f of 1. Yeah, just so I can know how tall it gets here and how deep it gets there. Yeah. No function tall.
And then when we add all the multiplicities, we know that it's a multiplicity of 4.
Be careful. Multiplicity refers to how often a 0 happened.
Okay.
So it doesn't say anything about the whole thing. So this 0 happened twice. This 0 happened once, and this 0 happened once.
But
The
but it would-
degree of the function
the degree, yeah, sorry.
is a 4th degree.
4th degree. Okay.
Yeah.
But that's a way to check it is if we add the multiplicity, we know the degree.
Yeah.
Okay.
Yeah. And again, the reason that is if I multiply x times x squared, that would be the highest power if I did multiply it out. Please, dear God, don't multiply it out if I give it to you factored, right? But just think, what would happen? What would be the biggest number I get, the biggest degree? 4.
I'm just trying
So
to.
then you know the end behavior.
I'm just trying to like make it make sense in my head why the graph is drawn that way, and that helps me.
Yeah, so I expect it to be up in these directions because this should be roughly next to the 4th way out here.
Okay.
Yeah.
That makes
Yeah.
sense.
You got the 0.00 from the first x, right?
Yeah.
Okay.
Because really, how to get the negative 3, 0? Negative 3 makes this 0.
Yeah.
2 makes a 0, and this is the freakiest one because it's too easy. Right? Some things that are too easy, we sort of make them hard because we're like, you can't be. But what makes that 0? If I make x 0. Yeah. So again, on a test, I do like to break it up for you, right? I'll say, determine the end behavior. I'll say, find all the intercepts. And when I say find all the intercepts, that means y-intercept also. I'll say, describe the behavior of the roots, or I might say, what are the multiplicities at each root and what does it do? I'll say that somehow. And then of course, sometimes I'm very nice and I say, find f of 2 and f of negative 5 and then graph. Like I give you a couple points that would help you. But we'll see how I'm feeling. You guys feel okay about putting a quadratic into standard form, the completing the square thing? Is that okay? Factoring is just, So I could give you a problem like number 1, but I could give it to you not factored yet, right? So then you just have to factor it first thing. Did I put that on here? Yeah, I don't think I put an inverse problem on here, but obviously there will be an inverse problem on the actual test. So did I not put an inverse problem on there? I sort of did. Like number 6 is the one-to-one thing, but I'm obviously going to ask you, find the inverse of this function. That's section 3.6 was absolute values, 3.7 was inverse, I think. So that's on this next test, yes.
When you're finding the point for the graphing that goes like down at the very bottom, it's like in between, how do you find that point again?
So this was 0 and 2, so that's why I would put a 1 in, right?
Okay.
Yeah, so just look at your intercepts and just pick any point that's between them to get some idea.
And you just put it back into the original equation.
Yeah, exactly. Yeah. 11.
You wanna know the point that's exactly in between them, right?
Doesn't have to be. That would kind of suck, because if I had intercepts at 0 and 5, I don't want to put 2.5 in. So put 2 in or 3 in, something in the middle, yeah. If you do take calculus, you will then make even better function. You'll learn how to figure out what the curvature should be. Ooh, Jeff, you're just selling me big on calculus. I can't wait now. That's kind of cool, right? Isn't there different curvature? Anyway. All right.
Are we gonna have any word problems?
Yes. Is that another one I didn't put on here? Let me think. The kind of word problem I would give you is just like the ones we've done. Sort of like the build a rectangle, try to find the biggest area, or I might just give you, all right, so either I'm going to give you one where you have to construct your own equation, or I'm going to give you an equation like the profit stuff we keep doing. Find the vertex, right? So what's the shortcut to find the vertex? Sorry? Yeah, negative b over 2a. So that's the x piece. And then to figure the y piece, I just plug this in to get the y piece. Right? Anytime I have an x, I just plug it in to figure out the associated y. Yeah. I like it. So for example, if I had $1 million, let's see. Find this guy's vertex.
Negative 16.
Good. Negative b over.
Negative 4 times 2.
Good.
2.
2. And that's the x piece. And of course, you know, y piece for the vertex. So the y would be, just plug a 2 in, right? Negative 16 plus 32 is 16, minus 1 is 15, I believe. Is that okay? So if this was a cost for somebody's lemonade stand, I'd say, what's the maximum cost? And you would say $15. Let's do this a different way. So that's the shortcut, right? That's the shortcut. Let's complete the square. You guys want to do that? No. Well, yeah, okay. You do, because right now it's just me showing you instead of me asking you. So let me write this again here. What would I have to do first to complete the square here? Couple things. What's kind of wrong about this currently?
The -4.
Stupid -4. So I take it out. Do I take it out of this? No, I can't. I don't. I just move him over, right? Move him over. And I take a -4 out of these guys. No job. And I leave some room. And hopefully at this point, the completed square part's pretty nice, right? What are the 2 steps? So looking in here, right? What are the 2 steps for completing a square? Say again? No? What? Say one more.
Plus -4 over t squared.
No. So you cut this guy in half. I don't know if you're jumping ahead, but I want both steps, because each step helps you. And then you square this guy. Right? Let's always cut the middle guy in half and then square. And we talked about why. We talked about why that's true. We saw a few examples, got some motivation. So what goes here? +4. What did I actually just do?
Added -16.
I subtracted 16. So what do I have to do at the same time? Add 16. And again, every year, less and less people have seen Indiana Jones and the Raiders of the Lost Ark, but the thing where he takes the statue and he puts the bag of sand, he just didn't balance it correctly, right? So if I take 16 away, I better add 16 so the boulder doesn't come down and crush me. Right? Okay. And then, so that's the second step, tells you what to put here, and then you balance it. And the first step tells you how this is going to factor. So now I know this is -4 times x minus 2 squared plus 15. What's the vertex? No. 2, 15. 2, 15, right? Same answer. Just this is a shortcut to that. Right?
Did you do something like number 7 on the practice test?
Oh, we did exactly that one.
Did I see that one? Is it on the board?
I don't think so. It was a while ago. You weren't here? I thought you were here. Right, you're looking at the long division problem?
Yeah.
Where x squared plus x, I don't remember, into blah, blah, blah. Yeah, we did that one. Yeah, I just didn't have enough room, that's why I wanted to do it in class.
Okay.
Yeah. Yes.
I got a question when you're doing the transforms. This one is like a 2, and then it's the absolute value, and then it's x -2.
Two absolute value.
X -2, absolute value, and then -4.
Yeah. Okay.
So when you're doing it, the 2 would be the second one?
Yeah, officially, yeah.
Well, it's like flip 2, or what is it?
It would only flip if it was negative.
Okay.
Negative tells me to flip, because negative means I change the sign of my output. That's why it flips out. This is just gonna do what to the outputs? Double them.
Okay.
Yeah. So whatever the output to this is, I'm gonna double it. So I'm gonna go right to,
And then double.
double outputs. You could also call it a vertical stretch. But why not just call it double the outputs, right? sounds better. And then the last thing I do is
Down.
down 4.
Wait, so if it was negative, how would that look?
If there was a negative here, there would be 4 transformations.
Okay.
I would write 2, double the outputs, flip it across the x-axis, and then move down 4.
Okay.
Yeah, if I saw a negative 2, the 2 doubles things, the negative flips things, right? So there would actually be 4 transformations.
Okay, so you
Yeah.
flip it and then you move down.
Yeah, exactly.
Okay.
As long as the last thing you do in this case is move down, you should be golden.
Okay, so for example, if it's at 1.11, it's gonna move to -1, -1.
Yeah, so if I have, so, all right, let's do this. Yeah, like there's the base graph, right? So I would move down 4. So I would move this one, right 2, bam, bam. Double the outputs, so it's gonna go, so right now it's at 1, so now it's at 2. And then down 4, 1, 2, 3, 4.
Okay, so you don't flip that one? Or
Yeah, there's no negative, sorry, I
okay,
took the
but
negative
if,
one.
but if it was a negative?
Oh, if it was a negative.
I understand that one, yeah.
Alright, if it was a negative, then I would reflect x-axis, and then I would down 4. So, let's take this point. If I take this point, right 2, 1, 2, double the outputs, bam, reflect across the x-axis, bam, and then go down 4. 1, 2, 3, 4. So I'll be way down here.
Yeah, I get it.
Okay.
Yeah.
Maybe. The crazy thing is, have we learned every function that exists? Have we learned every function that exists yet? Has anybody never heard of a function called a cosine? Most of you guys have heard. So we haven't officially talked about it in here yet, but could I use transformations on cosine? Yes. Any function, in fact, any relation, to be honest, any graph, I could keep track of the transformations and move it. So this idea doesn't give a shit what the function is. It doesn't care. It just always moves it the same way. Pretty nifty. What is due on Tuesday? Homework up through what? 5-4. Up through 5-4. What else? I heard corrections to what? Quiz 3 and test 1, right? Can you turn stuff in late? Hell yeah. How much will it hurt you? Well, the more you turn in late and the later it is, the more it hurts you, right? So normally if you can give me something the next day I see you, it's probably not going to affect you at all, unless it's a lot, right? Does that make sense? Because I think on the syllabus I have to go back and change it. I think I got a little more strict when I was online. I think it says homework only under when I have to give permission. No, you can turn chapter 1 homework in, you can turn it in on the day of the final, right? Are you going to get full credit for it? No, right? But you will get more than 0 credit, right? Because the final's cumulative. I want you to have a reason to do it. Or 2? Oh, I'm there. Okay. Oh yeah, this one. Okay. So it says find the area of a triangle. I think we started this one sort of once. Bounded by the x-axis. The line, what is it, 12 minus 1/3 x, I think? And the line perpendicular to f of x that passes through the origin. Ooh, boy. I think I told you guys that they put the hardest problems in this section right at the beginning. Perpendicular. So I got to find the line perpendicular to this one before I even think about anything else. How do I find the line perpendicular to that one? What's this guy's slope? What would you say to somebody that said the slope is 12? Why do you think they think the slope is 12?
Because it's in the back.
Because it's on,
So again?
because they think it's in MX plus B.
Yeah, they see the first number, they say it's a slope, but officially, where's the slope in front of the x, right? So b plus mx, mx plus b. So the slope of this one is negative 1/3, so what's the slope of the perpendicular line? 3. And it says it goes through the origin. What's the origin point?
0, 0.
0, 0. So does anyone see why this is such? This just goes right into the formula very quickly. Maybe quickly? Mx plus b, 3x plus 0. Hey, there it is. All right, so then we plot these lines, right? What's important is I'm going to make a triangle. Now, can you guys see if I draw this line, and I draw this line, and I draw this line? Have I made a triangle? Which parts of the lines don't matter if I'm just talking about the triangle? This part, and this part, and... Do you see how what's important is where they all meet? What's important is where the lines meet, because that tells me where the triangle starts and stops. So for example, isn't this supposed to be one side of the triangle? That's what they say. It says the bounded by the x-axis. That's one side of the triangle. So where does this hit the x-axis? What is the x-intercept for this?
0.
Now, how do you find the x-intercept? You make what?
Y.
To find the x-intercept, you make y0. So I can add 1/3. Multiply by 3. 36. Damn, okay, 36. What about, of course, this guy, I already know, 0, 0, right? So let me see. So somehow, if this was, this is not the answer. I'm gonna erase this in a minute. Let's say that line went that way and that line went that way. There's my triangle, right? Okay, so the next thing, and I have to figure out what that is. So let me give us, scale's not crazy important here, but it is a little important. It doesn't really matter. Okay, it doesn't really matter. I really want you guys to understand this. What's the last 2 things I need to see where they meet?
The other point of the triangle.
Yes, and what's going to make that point? It's going to be this line, right here. That's going to be this line. That's positive slope. And then this line is going to make this side. So I need to know where these 2 meet. Make them equal to each other. Yeah. So 12 minus 1/3 x equals 3x. And then solve for x. Right? So where do 2 lines meet? They meet where their outputs are equal. And then I can figure out what that input is to make that happen. How do I solve this? I would multiply by 3 first. Do you see that? Just to kill my fraction, right? I'm pretty good at math, but even I'm just going to kill a fraction if I can. 36 minus x equals 9x. Oh, this gets better and better. 3.6 is x. Ooh. So at 3.6 is where these 2 lines meet. Yeah, so I've got all my intersection points. What's the base of this triangle? 36, right? And what's the only other thing I need to know to figure out the area? The height. Now, I don't care about the sides. I want the area, right? Isn't the area of a triangle half base times height? So how do I figure out this height? Well, I just have to figure out what the y is at 3.6. So you can just plug that in and see what you get. Yeah, okay, cool. That's gonna have to be the same. So if you could just figure out what this y is at 3.6, you take half this times this, and you're done. Now, was that easy? Oh, hell, there's quite a few steps to that. So that was interesting that this book, it normally doesn't do that, but it decided to put one of the harder problems at the beginning. But really, so even if you start the problem, you have no idea what to do. What's the motivation? Okay, I need to draw the triangle first, because I need to know its base and its height. So then you start thinking, all right, I've got all these things. It depends on where they kind of meet. That's going to make my triangle. Okay. All right, so you got to kind of think, what do I need to know to be able to do the next step? Right? Would I give you a problem like this on a test? No. You're welcome. It's a little too involved, I think. It might maybe a bonus problem I give it to, something like that. Or if you guys believe me, that I have nothing. It's dependent on what you ask. Right? Okay. Now, wait a minute, did he leave? Have I given you the answer key yet? Dadgummit. Let's see if I can catch it real quick. He's gone. All right. All right, let's do this one also. Apparently, yeah, I should have just done this on another sheet of paper, but oh. I think 4D got lost in the shuffle. This one's a good one. So there's a specific point I'm trying to make with this problem. Do you guys see anything? How many terms are up here? 2, good. I love it. Do you see anything the two terms have in common? Nope, I don't either. Is one of the terms factorable? Yeah. Now be careful. What do you think comes out of here?
3A.
But how many of them are there? 2, right? So a 3, would I have this written twice? So if I took a 3 out, I actually do it twice. So it's a 9.
3 squared.
3 squared comes out. What else comes out?
A squared.
A squared comes out. So again, just to show you, wouldn't this be 3xa minus 3a times 3xa minus 3a? Wouldn't each of these give a 3? 9. Wouldn't each of these give an a? A squared. Right? So it's a shortcut on that. And what's left, it would be x minus 1. Now I see a lot of stuff. Common. What number can come out? 3. How many a's can come out? 2. How many x minus 1s can come out? 2. I like it. And what's left? 9 divided by 3 is 3. I had 2 a's, took them. I had 2 of these, took them. Bless you. Is that cool? how did 12 divided by 3 is 4. I had 5/8, took 2, so I have 3 left. I had 3 of these, and they took 2, so I have 1 left. And to be really honest, you could distribute, but it's not going to do anything. It's not going to be like terms. Right? So this was the freaky step from here to there. So real quick, if I had this, no, Jeff, you have to actually have, there you go, buddy. What can I take out of there? 2 to the 4th. I can take 2 out 4 times. 2 to the 4th. And 2 to the 4th is 2 to the 4th is 2 to the 4th power is 2 times 2 is 4 times 2 is 8 times 2 is 16. So again, 2x minus 4 to the 4th would just be this, yes? That's why you shouldn't have to write that out. It should be a shortcut. If I take a 2 out of this one, and a 2 out of this one, and a 2 out of this one, and a 2 out of this one, 2 times 2 times 2 times 2 is 16. 1, 2, 3, 4, x minus 2, so why not just do the shortcut? Oh my god. Okay, I think I did all the other ones, yes. Yes.
When you're factoring this equation right here, you got the 3 and the 4a cubed from the 12, right?
Yeah, the 3 here. So here's the first term. So I write what's left in the first term. So 9 divided by 3 is 3. Took 2 a's, took 2 of these. Plus 12 divided by 3 is 4. Add 5 a's, took 2, got 3 left. Add 3 of these, took 2, have 1 left.
Right. And then those brackets, how did you know where to place them?
Oh, alright. Let me see. Neither. If I said, factor this, how would you do it?
Take out the 3x, so we're bracket 3x, yeah. And then the 2, right?
What goes next? Be very specific.
Negative 2.
No. What do I put up, what do I draw up here next?
Oh, it's a parenthesis.
Ah, okay, how'd you know where to put that?
Oh, okay.
Right after the shit you're taking out, right? So here's the shit I'm taking out. And then I just made a bracket because there's already a lot of parentheses. So these could have been parentheses. I don't know if that's, I just made a bracket just because we already had a lot of parentheses. So this is what I'm taking out, parenthesis. What's left here? What's left here? Yeah. It just gets a little weird when there's more stuff in it, right? like 15 minutes of staring at each other. If you guys are ready, you don't have to stay. If you guys are like, I'm ready for this, you can head out. If you have more questions, ask them. If you just want to work on quiz corrections, feel free, right? Can you still turn in quiz 1 corrections? Of course you can. It's just late, so you won't get as many points back as you could have, but you could get some points back still. Yes.
On 4.2, I don't really understand the like linear, like modeling stuff.
Okay. Like for example.
I mean, I
Any-
don't know. I just pick a random one of the word problems.
Like the one about the population, maybe?
Yeah, that would work.
There's something about population? Okay,
Yeah.
so there's a problem that says, for example, the town's population has been increased at a constant rate. In 2010, the population was 46,020. By 2012, the population went to 52,070. Assume this trend continues. You guys see 2 points in there? Or is that the kind of problem you're talking about, or?
Like those ones, I'm good on.
Those
Those
you're good.
ones, yeah, I feel fine on. It's the ones later on,
Like the newborn baby? No.
yeah,
Yeah?
those ones
Okay.
would be good.
So the weight of a newborn, right? At T equals 0. Born, bam, 7.5 pounds, right? And the baby gained 1/2 of a pound each month for its first year. You guys with me? Which one of those has to be a constant? That number itself can't change. I mean, it's just the initial thing. 7.5. Now, that number, the weight of the baby starts at 7.5 pounds, right? So you can actually look at that. You don't have to, but you could look at it as a point, but you really, really don't have to. How do you figure out how much the baby weighed after 1 month? So at 0 months, it was just born, 7.5 pounds, right? Just born, 7.5 pounds. A month later, all right, so this is T, this is W. 1 month later, how much will it weigh? Yeah, 8 pounds, right? So it'll be 7.5 plus 0.5, right? Right? Okay, 2 months. How much will it weigh? 8.5, right? Every month it gains a pound, yes? At least for the first year. Hopefully that picks up a little bit. So this is 7.5 plus 2 of these, right? Each month, 0.5 pounds. You shouldn't have to do what I'm doing though. It starts at 7.5 and every month it gains 0.5 pound. So if you do this, you're not right. Because how many 0.5 pounds does it gain? Well, you have to tell me how many months it's been out and about, right?
0.5 times T.
Yes. Did they give us a variable? Yeah, T. So the weight is 7.5 plus 0.5 per month. So any problem where it's like, you call the psychic hotline, and it's $4 plus $7 a minute or something, right? Holy shit, don't call that hotline. It would be 4 plus 7 T equals the cost. So the per, very often, the per is where your variable is going to go. Half a pound per month. So 0.5 times T. Okay, maybe. Are you guys all cool with the fact that 7.5 is the starting point? That's like the Y-intercept. That's his W-intercept, 0, 7.5. And how much does the weight change on top of that? Half a pound per month. So what about 3 months? Wouldn't you take half a pound times 3 to figure out and then add it to 7.5? They're gonna break through. I don't know what's gonna happen. This is weird. Okay. Maybe no, is that better? Is that all right? No, that sucks. So that one, there's a lot less work to do because they basically give you the y-intercept and the slope. So very often when you see per, right? If you joined a gym and it was $200 and then $35 a month, what would the equation of the line be? $200 just to join, $35 per month. 35T plus 200. You start at 200 and you add $35 every month. So those kind of problems right there, they give you B. They give you M. You just have to recognize that's what they are. And that's why some problems are like, find the y-intercept, interpret what it means. Find the slope, interpret what it means. Right? So real quick, what's the slope in general? Isn't the slope the change in y over the change in x, blah, 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 right? Y is over x is, correct? What would this slope here be? What's the y variable in this? Isn't it the cost? And what's acting like x? Time. So then this would be in units of dollars per month. Isn't that dollars per month? So that's why the per very often is the slope, because what is a slope? It's a rate of change. Something per something, y's per x's. Maybe. So that per word, I know they didn't say per, but we know where it says half a pound a month, so per month. You could just put per month there. That's more than likely the slope, because it's a rate of change. Yeah, see, this is another one. Well, let's see. Yeah. This is one that they give you points. I don't know if they give you another one like that baby weight problem. Nope. Okay. Most of these problems are all about, can you find 2 points and then just find the slope and make the equation line. That baby weight problem was better. They just told me the slope and the y-intercept. What's the y-intercept in general? It's for like a physical situation. What would the y-intercept really mean?
Starting point?
Starting point. Kick ass, right? So the baby started at 7.5 pounds. Starting point. And then the slope tells you how much that's changing over time. So that's why it's plus half a pound times t. Because every month it's gaining half a pound. Okay. Anything else? I don't know if you guys believe me when I say I have nothing. I've brought nothing. It's all dependent on what you have to ask.
I'm still having a hard time factoring cubes, like the 3w minus 8, for example, or w to the third minus 8.
Yeah, so the first step is w cubed is www, right? 8 is
-2,
2 times 2 times 2, right? Little dude, big dude, 1 of each, 2 of each, product in the middle. 1 of each, same sign. 2 of each, product in the middle.
and then flip the sign.
Yeah, change the sign, because this guy's job is to kill the other shit I don't want, so it's got to have the opposite sign. So do you see how you get your W cubed?
Mm-hmm.
Check. Do you see how you get your -8? check. But you also get this other shit you don't want, so that's what this guy does. Do you see how I get negative 2w squared? I don't want it, but look, what's w times 2w? Plus 2w squared. Die. I also get minus 4w. Do I want that? No, but what's w times 4? 4w. Die. Right? Why are squares easier? Because there's less shit in squares. I can cut them exactly in half. Cubes, I gotta cut them in thirds and 2/3, right? Thirds and 2/3. It's a little bit freaky. It's not symmetric. It's not balanced. That's why it's got an extra term there. Shit. I'm really curious if I'm gonna see some faces on Tuesday I haven't seen in a while. We'll see. Oh.
For the corrections, do you want me to write them on a separate piece of paper, or is this appropriate?
What's the answer?
Do you want me to erase this one?
No, don't change the original. Never
Okay.
change the original.
Alright.
But you can do it on here if you can make it really clear what your correction is.
Can I try an arrow?
Sure, yes.
Okay.
Thank you.